Now I want to focus on an example where we're actually going to find the standard deviation and the mean for what we're calling grouped data. And it basically works the same way, but what we're noticing with this particular example is that we have a lot of repeated values. And we have quite a lot of values here, right? So if we were trying to do this by hand to find the mean or the standard deviation, this would take a very, very long time. Now we have technology. So I'm just going to do one example on the grouped data, but where we have technology, it's really not that big of a deal anymore. So what you could do is just put all these data points into your calculator or into Excel. So it may take you a minute to do that, but then we can actually find the mean and standard deviation very quickly once the data is inputted into technology. So that's another way to go about doing this. But if you want to do it by hand and you have a lot of repeats in your data set, here's something you can do to kind of help speed along that process. So the first thing I'm going to do is I'm going to notice that my data is all between 0 and 6. So my minimum value is 0, my maximum value is 6. And what I'm going to do, I just have each of my data points listed, is I'm going to count up how many of each of those I have. So using or counting that frequency. So if I start with 0, I see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 data points. Then I would do the same thing for 1. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And then I'm going to continue on and figure how many 2s I have, how many 3s, and so on. And I've already done this on the side. So I have a 7 here, a 7 here, 2, a 1, and a 4. And in this problem, we want to find the mean and then the standard deviation. So we're actually still doing the same process for finding the mean, right? So normally when you find the mean, and I do have a sample here, so I'm going to use the X bar notation. What you would do is you add these all up, right? I do 1 plus 3 plus 1 plus 1 plus 1, etc. And then I would go ahead and divide by the total. And let's see, how many do I have all together? I actually have 50 data points all together. So once I add those all up, going all the way out to this 4, I would divide that by 50 and find the mean. Well, there's a shortcut here that we can use instead because we have a lot of repeats. And we're going to actually use the frequency. So instead of writing 10 zeros in the problem or 19 ones, I can do it with multiplication. So what we're really doing is taking that 0 and multiplying it by 10, right? Because there's 10 zeros. And then we're doing the 1 and we're multiplying it by 19. And then the 2 and we're multiplying it by 7. And then the 3 and we're multiplying it, by 7. And then the 4 by 2, the 5 by 1, and the 6 by 4. And then we're still going in and we're dividing that by 50. So this is just a shortcut way where we have a lot of repeats instead of adding things one at a time, particularly if we're doing it manually or doing it by hand. We can save some time. So instead of writing 0 10 times, I just write times 10. Instead of writing the number 1 19 times, I write times 19, and then I can find out my value there. Now, I just made a table here to maybe make the multiplication a little easier. So 0 times 10 is 0. 1 times 19 is 19. 2 times 7 is 14. 3 times 7 is 21. 4 times 2 is 8, excuse me. 5 times 1 is 5. And 6 times 4 is 24. So what my mean ends up being here is 0 plus 19 plus 14 plus 21 plus 8 plus 5 plus 24, all divided by 50. And what you get is 91 over 50, which is about 1.82. Typically, we round to one extra decimal place than what we start with in the data set. Again, if something in my math lab says differently, defer to whatever the problem says. But if you're not told, usually you do one extra decimal place. So my mean here is about 1.8. Now we can use the same sort of idea for the standard deviation. So if I'm finding the standard deviation by hand, again, I can use technology here. So if I'm using technology, then you don't have to worry about any of this. You're just going to input the individual data points into your Excel or your calculator and run the usual computations, and it can find everything for you. But if I'm doing this by hand, I really don't want to subtract 50 values from the mean one at a time and square those and add them. It's a huge mess, right? So we're going to use the same idea because we have repeated values over and over again. We're going to start with just doing one of them. So just doing the 0, the 1, the 2, the 6. And then we're going to use these multipliers here like we did for the mean, but also for standard deviation. So let's do a different color first. So now I'm going to go ahead and find that standard deviation. And I'm going to set up a table here again. And when we find the standard deviation by hand, the first thing we need to do is to take each data point and subtract it with the mean. So again, I'm just going to do this for each individual data point one time instead of doing it all 50 times. And then I'm going to multiply by however many of those I would have in the end. So the first data point I have is 0, and again, my mean is 1.8. So I'm doing 0 minus 1.8, which is negative 1.8. Then I'm doing 1 minus 1.8, which is negative 0.8. Then I'm doing 2 minus 1.8, which is 0.2. 3 minus 1.8, which is 1.2. 4 minus 1.8, let me move this up, which is 2.2. 5 minus 1.8, which is 3.2, and 6 minus 1.8, which is going to be 4.2. So my first step is to still find that subtraction with the mean. Now I'm using the rounded value here. You could also use the original value, which would maybe be a little bit more accurate. So if we did that, if I wanted to use that 1.82, then this would be negative 1.82 to here. So instead I had a 18 at the end instead of 0.2. All right, so I'll stick with that way to make it a little bit more accurate, and using the full version of the mean rather than the rounded version. And then there's going to be my subtraction. Now what we do next is we always square next. So I'm going to take those values and I'm going to square them. So I'm going to take that negative 1.82 and square it, that negative 0.82 and square it, the 0.18 and square it, 1.18 and square it, 2.18 and square it, 3.18 and square it, and 4.18 and square it. 1, 2, 3, 4, 5. All right, so I have them all. And what I get there from my values, let's see, I already did this out. So I have 3.3124, 0.6724, 0.0324, 1.3924, 4.7524, 10.1124, and then 17.724. Now, again, you would do this for all 50 data points, but because they're all repeated over and over again, the same 7 values, I can use that frequency, just like I did up here, as a shortcut. So instead of doing this 50 times individually, I now have my main values, and I'm going to multiply that by however many I have. So I don't have to keep doing this over and over again. So it's written like this, but squared. But do remember that if there's no symbol between it is multiplication. So all I'm doing now is I'm taking these squares and I'm multiplying by the frequency here. So in the first case, I'm doing 3.3124 times the 10, right? Because I have 10 zeros. And then I'm doing 0.6724 times 19, 0.0324 times 7, 1.3924 times 7, 4.7524 times 2, 10.1124 times 1, and 17.4724 times 4. So I'm going to get all these calculations. And let's see, you can see this is a really tedious process, right? Which is why I do recommend using technology if you can. So if you like to do it by hand, I do recommend trying it like once or twice, particularly just regular standard deviation, so you understand how the process works, so that you understand where these values come from, right? So I know we use technology a lot, and I highly encourage it because it saves much time, but you should still understand how the technology is working. So this is what your calculator is doing in the background. We don't see it, right? But you're still finding those differences from the mean. So we're still doing this average of the deviation from the mean here, and your calculator is doing it much more quickly for you, or your computer. All right, so let's see. We get 33.1240. I'm just using 4 decimal places. Let's see, 12.7756, 0.2268, to 9.7468, 9.5048, 10.1124, and the last one, 69.8896. Now remember that the standard deviation is still a kind of average. So once we've done our subtraction and we've squared everything, now again, I've multiplied by the frequency so that I don't have to do this 50 times. I add everything up, just like we did up here. So we're adding all these values up, and when you add them up, what you get is 145.38, just using 2 decimal places. And finally, for my standard deviation, now remember this is a sample standard deviation, so I'm going to use S notation here. What I'm going to do finally is take that 145.38, and I'm going to divide it by my sample size minus 1. So when you have a sample, don't forget you don't use the full sample size, you subtract 1 from it. So I'm going to divide that by 49. If you had a population, then you just divide by the regular n. But for samples, you divide by 1 less for standard deviation. And then, so there's my average, and I take that square root of it. And what I get is about 1.7. Now, it's the same units, so if we go back up to the question here, I kind of skipped the question. It was the number of children per household. So the mean number of children per household in the sample would be 1.8 children, so about 2 children. And then for the standard deviation, about 1.7 children. Again, about 2 in real life, right? But for our calculations, even though obviously nobody has 2 children, or nobody has 1.8 children, these would be your answers for mathematical purposes.